Hello, my name is Lance Finney. I'm a software developer and consultant with Angular Code for Valiantis and an instructor with Angular Bootcamp. And I'm recording this to talk about the Angular Renaissance, key new features in 2023. Now, before we talk about a renaissance, we kind of really need to know the history of Angular. So here's a brief history. Google released AngularJS in 2010. And it was a groundbreaking new web framework at the time. It really led the game in single-page web applications. It was really popular. It got a lot of attention. It really was the best at the time. Unfortunately, the core team at Google realized at some point that there were some major architectural problems with what they had, and they wouldn't be able to build to the future with what they had. So they decided to start from scratch and build a new version. And that new version came out in 2016, and it was called Angular. It wasn't just a new logo and a new name, dropping the JS. It really was a new framework, completely from scratch. And while it was much, much better than its predecessor, it was a completely new framework. So there was a long delay between the releases, and there was not really a great migration path from the old way to the new way. So even though it was a much better framework, other innovations had happened with other frameworks, and the Angular community lost some momentum. But it was a really good framework. And there was a lot of innovation at that point and a lot of growth. But then after a few years, the core team realized some more architectural problems that needed work. There were just some things that they couldn't do with the compiler they had. Now, they learned their lesson and didn't start from scratch, didn't make everyone throw away their old work and start on a new one. They created changes within the framework. They essentially replaced the engine of an airplane in the air. So we did not have to do huge rewrites like we did previously, but there again was a period where there were not a whole lot of very compelling visible changes in Angular because they were working on the internals instead of giving us new features. Now, the promise they were giving us was that the new approach, through something they called Project Ivy, to rewrite the compiler and renderer, would open up the door to a lot more innovation in the future. And that promise was fulfilled. Within the last year or so, we have seen a lot of innovation in Angular, and there's a lot of excitement about it now. So the promise of Project Ivy was fulfilled. And now, with Angular 17 having come out a month ago, there's a lot of buzz, a lot of excitement about Angular and its new developer and user experience features that have parts of Twitter and social media buzzing positively about Angular in a way we haven't seen in a long time. So to talk about why we have such buzz, I'm going to talk about four major features of what have come out in Angular in the last year. And since I have four of these topics to cover, who better to help me cover than four people who probably know as much about the Renaissance as anyone else? Raphael, Michelangelo, Leonardo, and Donatello. So they'll give us some help. We're going to start with Raphael talking about standalone components. So what changed? Angular, like all or most other frameworks, uses components as the core level of reuse. But it was a little bit different with Angular than the rest, because a component in Angular wasn't truly standalone and reusable. Every component in Angular needed to be registered, declared in another file called a module file. That's not something that other frameworks made developers do, but it was necessary in Angular. And dependencies of components were not defined in the modules themselves. They were defined, not defined in the components themselves, but were defined in those separate module files, which was just a little weird. What we ended up with was the module with however many components that module contained. One component or dozens was truly the smallest unit of reuse in Angular. And that was a larger level than with other frameworks. And there was this additional concept of a module that other framework ecosystems didn't have and didn't have to learn. But now with standalone components, components are, well, standalone. They essentially are their own modules. They contain their own dependencies and declare them. So an individual component lives on its own. This creates a simpler mental model for us because we don't really have to think about modules anymore, but it brings some other advantages that I'll talk about soon. So here's an example of a converted component that Raphael did so that we can see what changed. On the left, we see the old component that was in their application. It's a sewer component that models their hideout. It's called sewer component, the selectors TMNT sewer. There's not a whole lot of state here yet. The only state is a Boolean to determine whether the manhole is open or closed. And if it is open, there's a message that says something. It's in another component. I'm not sure what it says, but there's a welcome message if it's open. Additionally, there's a button where you could open or close the manhole, and then the text on the button was relevant to whether it was opening or closing. On the right, we see what this component is now, and it's almost identical. The template hasn't changed at all. Most of the TypeScript hasn't changed. There's actually just a new word there, default, that is only because this is a routable component, and we'll talk a little bit more about that later. Truly, the changes were just 2 lines of code. In our decorator, in the metadata at the top, we added 1 line to say this is a standalone component, and another line to declare what this component needs. This component has an if to determine whether to show the welcome, and so it needed to import both of those things. Previously, those imports were done somewhere else, but now this component takes care of that itself. So you might look at this and say, wait a minute, the changes here, we added 1 word and 2 lines. Is this worth it? We're actually adding code. And the answer is yes, it's worth it, because ironically, the main change that happens for standalone components doesn't happen in the components themselves. It happens in the modules. So here we see the previous module file that contained that component. The sewer module declared the sewer component and the welcome component so that they lived together in the same module, and the sewer component could use the module, use the welcome. Additionally, that import line brings in the common module, which contains, among other things, that ngIf that the sewer component used. So the dependencies were defined in this file outside the sewer component, and the relationships were defined outside the sewer component. Additionally, the sewer component is a main routable component. You could route the entire application to show the sewer component. That's what router for child routes sets up, and the routes at the top say, when we route to this module, show this one component. So the declarations are gone because the components take care of that themselves. The common module is gone because the component, again, takes care of that itself. So where does that routing go? That's the one last piece. And the answer is, we just don't need this level of routing anymore. What you see here are the main bootstrapping configuration files for our application. The top file on the left and the file on the right are both main.ts, which is the true source of bootstrapping. In the old way, we had a single line there that essentially said, when the browser loaded, bootstrap the module called the app module. And that's really all we had in that file. And that's the way most main.ts's have been in Angular. Just one bit of boilerplate and not much else. You can see on the right that has changed now, and we do more in there. But that more was in a different place. It was in the app module we see on the bottom on the left. So the main.ts bootstrapped us to this module, and that module bootstrapped us to a component. So there were 2 levels of bootstrapping, from the root to the module and the module to the component. You can see on the right, now we go from the root to the component. We just skipped that level of indirection, that intermediary we didn't need before. Additionally, this is where basic routing was set up. From the root of our application, we would route to the sewer module, and then in the previous file, the sewer module would route to the component. The reason we were able to get rid of that in the sewer module is what you see on the right. We route now directly from the root to the component. We just don't need that level of indirection. And the APIs have changed a bit. In the old way, we would import the router module and configure it for root for those routes. Now we provide those routes through provide router. So a different API. Takes a little while to get used to, but it works. And the API for the routing itself has changed. Previously, we would use load children to go to the module, again, with the module separately going to the component. But now we use load component to go directly to the component. And this line in here is why we had to add default earlier. So, was it worth the hassle of adding those 2 lines to the component? Well, we were able to get rid of 2 complete files and clean up and simplify what was left behind. So yeah, it was worth it. And we're going to see more advantages later. So this is actually a fulfillment of the original vision. You may have wondered when I said Angular and only Angular used modules, why it had them. Well, that was not the plan. I started using Angular 2 in the alphas. And then through the alphas and the betas and in the first two RCs, there were no modules. The components declared their own dependencies. However, very late in the game, the core Angular team in Google realized there was a corner case involving some dynamic components where they just couldn't load them that way. The compiler at the time couldn't handle it. So they had to add the modules as a band-aid. And it's a band-aid we've lived with for a while, and it works, but it was always just kind of an unnecessary concept on top, and now we don't need it anymore. With Project Ivy, the compiler is more capable, and it can do what the previous compiler couldn't, so we don't need the modules at all anymore. The status of this is that it was introduced in Angular 14 and 15 at the end of 2022, early 2023. We got much better tooling in Angular 16, so you can write a command line command that will convert your application for you. It doesn't do everything. It mostly works on the components and some stuff with the modules, but there's other things like routing changes in your module that you'll have to do yourself. But it does a lot of the work for you. And now, in Angular 17, as of a month ago, this is the default. So if you have the opportunity to use standalone components in Angular, I highly recommend it. So thank you, Raphael. Now Michelangelo is going to talk to us about signals. What are signals? Well, they're a new synchronous reactive primitive. And I put new in quotes because they're new to Angular, but they're not new overall. They've existed in some other web frameworks under different names sometimes. And even if you're not used to web frameworks, you've seen stuff like this before probably. If you've ever worked with a spreadsheet where you have a column of values for each month in a year, and then at the bottom, a summary for the whole year, you've probably set it up so that when you change a value for one of those months, for October or June or whatever, it automatically changes the total. That's essentially a signal. The month values are little boxes that contain a value, and if there's another value somewhere else that is calculated based on them, that depends on them, when you change the first value, the other value is automatically, instantly changed for you as well because it handles that notification. That's what signals essentially are. Now, if you're already familiar with Angular, you know that we already have a reactive primitive of RxJS observables. So a lot of people see signals and think, wait, is this replacing what we had before? And the answer is no. This is a new type of reactive primitive. RxJS observables are asynchronous. They work over time. Signals are synchronous reactive primitives. They only have a value right now. They don't know what value they had before, what value they have in the future. There's no way to delay things. They just know right now and how to tell other people or other parts of your code that something has changed. So observables and signals work together and solve different problems. So what problem needed to be solved that caused them bringing in signals? It's all about change detection. The default way that we have had for a long time to do change detection in Angular actually feels like a bit of magic. It uses a third-party library called zone.js. And the way zones work is it's keeping track of your whole application for you and updating things on the fly. And as I said, it can kind of seem like magic. The first time that you work with an Angular app and you make a change in data over here, and suddenly a component over here will redraw itself because of the change over here. And you don't have to send a digest message or anything like that. It just automatically happens. How does that work? Essentially, well, look at this example here. Imagine this is our component where we have a parent, or an application where we have a parent component, which has a couple of child components underneath it, and then there's a grandchild component below one of them. Let's say the user changes some data in the grandchild. What will happen is Angular will notice, or zones will notice, that a change has happened, and then we'll ask every other component in your application, is there any change that has happened in you that I need to know about and redraw? And it works magically and really, really well for small applications. But for large applications, it tends to have some problems. It can bog down. It can be slow to have to check your entire application. Now, it's a really fast process overall, so your application has to be pretty big before you see the problems, but you can see the problems. There's an additional, more fundamental problem, though. Zones works through something called monkey patching. It's actually changing the way that JavaScript works in your browser to be able to watch for any change that happens in order to be able to redraw it. Now, some people just don't like that sort of thing philosophically, but there's an additional problem that there will be changes coming up in JavaScript soon that are not monkey patchable for this. So zones is kind of hitting a limit. What other approaches do we have, though? There's another approach that's built into Angular called onPush. You can declare an individual component, like, say, this grandchild component, to be onPush. And then when a change happens to it, Angular won't check the entire application, but will just check that component and its parents up to the root. So this can be a huge performance improvement, but there's some costs to this. One cost is it's not as magic. Now, Angular will still watch some changes for you and automatically re-render as necessary for some changes, but there are other changes, like if you're changing the value in a mutable object, where it will have no idea a change happened, and you as a developer will have the responsibility of telling the system through a service call that the change detection system needs to rerun. And that's a little annoying, but it's not horrible. A bigger concern is that onPush breaks standard change detection. So imagine that this grandchild component has other components underneath it. When normal change detection happens, it starts at the root and will come down to this grandchild, and because this grandchild is onPush, it will stop the change detection from happening anything underneath it. So whatever's underneath this grandchild also needs to be onPush, which maybe is fine for you, maybe you can do it, but what if you want to bring in some third-party component from some library and put that under your grandchild and it's not onPush itself? That means change detection just won't work on it. So it's better on performance, but it has some issues. And this is where signal-based change detection comes in. Because those signals can notify when a change happened with them, our system should theoretically be able to know exactly what has changed and be able to redraw. So if our grandchild component were signal-based and a change happened to it, only the grandchild component would be changed and it would be notified that a change happened and it would redraw that. And even better, because these signals are happening on a specific thing in the template, the particular specific part of our component that has changed could be redrawn, not even the entire component. Better, if there are other components underneath the grandchild, normal change detection will flow to them as well. This won't be like onPush and block them. This won't change anything other for change detection, and if you use signal-based change detection, you'll have great performance. So it sounds like it's perfect. What's the problem? Well, it doesn't actually exist yet. It'll come soon, and they're working on it, and they have parts of it, but they don't have it at all. But let's see the usefulness of the parts that already exist. Let's go back to the sewer component. Again, there's one bit of state in here where the manhole is open. And you can see on the left how we would implement it in the old way with standard change detection. The template will decide whether to show the welcome component based on the value of the manhole open. And we'll have a button there that when we click it, it will toggle the value of that to say that it's open or closed. So automatically, when I click that button, the welcome component will either be shown or hidden based on that new value. And change detection will detect that something has happened and will redraw it for us. Additionally, our button has text on it that says whether it's going to be closing or opening, and the text changes based on that flag. So again, when that state changes, that will be re-rendered as well. Our change detection system is watching things and making that change for us. This works great for a tiny app. But what if we wanted to have full control over what was redrawn? We can do that with signals on the right. Now the manhole open, instead of being a pure Boolean, is a signal. We wrap it in signal in parentheses, and it becomes a writable signal. So now, when we're trying to decide whether to show our welcome component, we can get it out of that box by putting parentheses after it. So manhole open with parentheses is the equivalent of just using the Boolean before. And it works just fine. Then, with our button, if we want to change the value, this writable signal has a set method on it. So we can take the old value, negate it, and put the new value in. And when that happens, that signal has or knows that it got a new value and will notify anything that's listening that it has changed, including that welcome component. So that welcome component will either show or hide depending upon that new value going in, and it will automatically happen, and we don't have to notify anything, and it doesn't require a system to be watching everything. We have told it simply how to do that. Additionally, we have the button text on there that would also change whenever we click on it. And we could have done the same thing in here, putting in the manhole open and leave that, but we wanted to show a different ability here, the computed signal. This is a read-only signal that is generated off one or more other signals. In this particular case, computed receives a callback that contains a reference to the manhole open signal. And every time the manhole open signal gets a new value, including its initial value, it calculates whether to say close manhole or open manhole, and the button text with parentheses up at the top in the template gets that value and shows it. So every time we click that button, it notifies the welcome component whether to show or hide. It notifies the button text read-only signal whether to reevaluate, which itself then notifies the button text whether to redraw. So definitely more code than before, but we have simple tools to tell the system when to redraw. A slightly different way of doing the same thing is to use a different method on the writable signal. In addition to set, where we just give it the new value, we also have update, which takes a callback, which gives us the old value. And in this case, since the new value of the manhole being open, the new value of that state is totally dependent on what the previous value is, it's just a negation, this is a perfect use for us. So we can have a method that says, this.manhole open update, take the old value, negate it, and put it right back in. Overall, it ends up doing the same thing as the other approach, but it's a little bit more explicit on how exactly it works. Set and update exist on writable signals. They don't exist on read-only signals. We can't call them on button text itself. Those methods just don't exist. But when we have our writable signals that we control, that's where we have the ability to control them. So that's the basics. Let's talk about how it interacts with ArcsJS. So here's a component, or a set of components in an application that Michelangelo has written in order to keep track of the villains. So when we initially load it, it makes a call to the back end to get 10 values of names of villains. And then at the top, there's a reactive forms form control where we can type in a part of a name and it will filter it down. When we type in rat, there's only one in this list that has the name rat. We filter just to that. We want to pull that back. We want to get all of them that have RA in their name. And then we get 4 options. And if we click on any of those options, then it makes another call to the back end using the ID of that option that was selected to get the full information about backstory, affiliations, and weaknesses. So there are several different sources of data and input here. We make a call to the back to get the full list or a filtered list, and a call to the back to get the full information about an individual villain. And then the user can give information in for the filter to say which subset of the villains they want, and then click on an individual villain name to get the ID to make that request to the back. So let's look at the code for this. On the left, we see it done purely in ArcsJS, and this totally works. But it involves the existing change detection systems, either zones or on push, and we don't have as fine a control of that. The way this works, at the top we have our name filter, which is a reactive forms form control for that text input. We have 2 different observables that we are going to use to display information on the screen. Filtered list shows that list of 1 to 10 or however many villains at the bottom, and selected villain will show the information at the end. Selected ID is a subject, which is a special type of observable that received the value of which one the user clicked on in order to be able to get the full villain. The way that we get these observables then is shown in the constructor. We get the filtered list starting with that form control. And that form control gives us an observable called value changes that has every single value that as the user types in there. Now, that observable does not start with the initial value, which we want. So we have to call start with to add that initial value. And then we want to be nice to our server and not have it send a new request every single time someone types really quickly. So we have a debounce time, which in this case says, let's wait 250 milliseconds after the user has stopped typing before we make the request to the backend. And then once we have that resting value, we use that with SwitchMap to make a call to the server, which takes however long the network lag takes to get that value to bring it back, and we have our full list then, which we can put on the template on the screen using an async pipe, which manages our subscriptions and unsubscriptions and getting the values out for us. The selected villain is simpler. It starts with that selected ID subject where the child component gave us that ID. And then again, we switch map on it to make a call to the backend to get that value that we bring in an observable and display on the screen with an async pipe. On the right, we see the combination where we're using the best of both RxJS and signals. So again, we have a form control to start. But now our selected ID comes in as a signal from the child components, and our results that we're sending to the screen are with signals, not with observables. So when we put them to the screen, we don't need to use async pipes. We use the parentheses at the end, and that gives that information to the template so it knows when these changes have happened. But signals can't do everything. Right now, there is no way to get a signal from a reactive form directly, so we need to use the observable approaches to get those values out. And signals are synchronous. They have no concept of time. So they have no concept of waiting a quarter of a second for the user to stop typing or waiting for the value to go to the server and come back. So all of that has to happen in RxJS, and then we can convert it to a signal when we're done. However, a signal can't just assume a value is going to come. That's just not how they're built. Observables can, but signals can't. So we need to give it an initial value so that it has something before things come in. It just can't wait for the quarter second plus and the network lag to have a value. We need to give it an initial value. By doing that, we are allowed to have the type of our filtered list be a signal of an array. If we didn't put that value in there, it would have to be of a type signal of villain array or undefined, which would work, but it's just a little bit uglier. It's easier just to put in an initial value. For our selected villain, we start with our signal of the selected ID, and we want to make a call to the backend to get that value. But again, signals can't do that. Observables can. So we convert our signal to an observable, then use observable operators to use switch map to make that call to the backend, get our value, and when that's done, we convert that observable back to a signal to have our value that we can put on the screen with our parentheses. And in this case, we don't have a selected villain at the beginning anyway, so there is obviously going to be a time that we can have the villain or undefined be the value of the signal. So it's totally okay not to have an initial value in this case. Now, what if we wanted to do something like this, where we wanted to react to a signal value, but not to create a new signal like Computer does, but to do something, to have some sort of side effect? That's what we can do with the last part of the existing API, which is effect. The way we would do that sort of thing in RxJS is on the left. We would start with a filter text observable and subscribe to it. To get that value out in the subscription, we'd have a callback where we're given that filter text, each value that comes through, we'd have it. And then we can pass it to, well, do anything. In this particular case, we're going to update the query params to put the filter text value in to the URL bar. We can do essentially the same thing on the right with signals. We'll start with a filter text signal, and then we also could have a callback and we can call update query params. But instead of getting the value as the argument to the callback, we make a call to the signal with the parentheses to get that value out within the effect. And then every time filter text has a new value, it will re-evaluate this callback and re-update the query params with a new value. So these two are very symmetrical. The difference is that no subscription cleanup is needed. In the RxJS world, every time you manually create a subscription like this, you need to take care of manually cleaning up your subscription, or else you'll get a memory leak. And that's what that take until destroyed is doing. That's cleaning that up when this component life cycle is over. We don't need to do that with signals. I put an asterisk on this note though, because our signals doesn't really know what you're doing in that callback besides using another signal. So you could be doing something in there that needs cleanup. But the normal behavior, the 99% of the time, you don't need to do the type of cleanup you need to do with RxJS. So what's the status of all this? It was released in the middle of 2023 in developer preview and mostly went stable in Angular 17 in November. Not the effect part, they still want to work on that. But what's the future hold? Here's a slide from Alec Rickabaw's talk at the beginning of December in Vienna at NG Glühwein. And it shows the plan to get to signal change detection that I showed earlier. It's at least a 5-stage plan, of which only 1 stage is done. So we want to get to full signal change detection, but we're not there yet. What we have is still useful because we can use it with the change detection right now and have more control over what's going on. But it's not there yet. And the best practices that seem to be emerging are that for our back end, we'll do RxJS. Observables are great to talking to the back end. In the front end, we'll use signals to put data into the template. And there'll be some sort of service layer in between where we'll convert back and forth with toSignal into observable. But we'll see. It's a new and an early thing, so we'll have to find out what the actual best practices develop as. So thank you, Michelangelo. Now we'll talk with Leonardo about the new control flow syntax. So Leonardo took the sewer component that Raphael showed us and made a change. In addition to showing the welcome component when the manhole is open, he wanted to add a message to say stay out when it's closed. And the syntax for this is just kind of weird. Now, it was already weird that ngIf was this star thing, which means it was a structural directive that lived within the thing it was controlling. And because it was a structural directive, we had to import it into our component, or previously into the module. So that was weird. But then when we want to do this else, we say :else closed. And close is a variable that exists within a template. It's actually defined on the line below. This ng template could be anywhere within the file, but it's on the line below with a hash closed declaring that variable that is used in the else. So it's just kind of this weird non-symmetrical thing, and it brings in this concept of an ng template. What's that for? When do we use it? And can you imagine if we needed to do an else if? We would actually have to embed nested ngIfs inside this ng template and then have nested ng templates or something. It would get really weird. So we ended up not really using else ifs much. What we see on the right is a completely new syntax that just came out. That is so much easier to read. We say, essentially, if manhole is open, then we have a block, what we want to show as controlled by that block. Else, another block to show what's else. This reads so much more cleanly for anyone who knows JavaScript or any C-based language. We also don't have to import this thing because it's not a structural directive. It's built into the language at a much deeper level, so we just don't need to worry about that. If we had an else if, it'd be easy. We could say @if, @else if, @else if, @else. It's just really easy to read and understand. It does have this new syntax with the @ sign. So that's going to take a little while to get used to, but otherwise it's very, very readable. The for is similar. So in the old way, we'd say ng4 within an li. So in this case, we're building up a bulleted list of a bunch of pizzas. So ng4 for each pizza in this pizza's signal, so a signal that contains an array, we're going to show an li that will show the index, which we can also grab as part of the ng4, and the pizza name. So pizza is an object that has a name on it. So we'll have 1 sausage, 2 pepperoni, whatever. And then if we don't have any pizzas, I mean, that's a real bummer for the turtles. So we'll just say ngIf no pizzas, if the value in the pizza signal is an array that has no length, then we'll say bummer. That's the old way. Looking at the new way, We're also going to be adding LIs within a UL, so add bullets within a bullet list. But it's a lot more readable. At 4, pizza of pizzas, getting it out of the signal. Then there's track. I'll come back to track. Then we can grab the index again. It's a different syntax. Instead of index as I, we say let I equal $index. And then there's other things, $first, last, even odd, things like that. Then within the block, we have the thing that is duplicated. Li of 1 pizza or 1 sausage, 2 pepperoni, whatever. So again, now we have a for loop with a block where the thing we're duplicating is within that block. In the old way, we had the for loop inside the thing that was being duplicated, which was just kind of weird. The new way reads a lot easier. Additionally, we have this optional thing that we didn't have at all before called @empty. So we can say if there's nothing in that array, we will show bummer. And it's easy to read. It's within a block right there. We also don't need to import the ngIf and ngFor, so this is great. The last part of this is that track. I kind of skipped over it. This is a huge performance gain for us. What this is saying is for every line that we put in, even though the ID is not what we're showing on the screen, the unique indicator for each line in there is actually the ID of the pizza. So imagine we have 100 pizzas in a list, and pizza number 17, for some reason, we change the name of it. So we change what's visible on the screen, and it's a sorted list, so it drops it down in the list somewhere. If we didn't have any way of tracking, Angular would see, well, there's a few at the top that didn't change and a few at the bottom that did change, but then there was just this resorting, and it wouldn't know that there was really only one thing that changed. It would see that a whole bunch of things were changed because of all of the ones that were pushed up when the number 17 was pushed down. So it would just kind of re-render and redraw everything because it wouldn't really know what had changed. By giving it the track of pizza ID, we're saying the ID is the thing to track. So when we moved pizza 17 from here to here, it's the same pizza. We have to re-render that one because that one has new information. But all the other ones that moved up, those are the same things that we had before. We don't need to re-render them. And so we only really re-render the one and just reorder the others. It's a huge, huge performance benefit. Now, we used to be able to do this before, but it was a weird syntax called track by where you had to create a method in your component that got called. And it was just ungainly, so I know that I pretty much never did it. But now, because it's easy to do, you just say track and the part of the thing that you're tracking, and the performance gains are so big, it's required. So anytime you do an @for, you're going to have to put a track in there. The last part of this new syntax is with the switch. So here we see on the left that we are switching over the color to figure out which turtle to show. And if there's no color match at all, then we'll show splinter. So the syntax for this was really weird. We want to do a switch on something, so we have to use square brackets on an ng switch. And the thing that we're switching over, that doesn't display itself, but we need to have something somewhere to put it. So we brought in an ng container, which doesn't show up in the template at all, but we just needed it to have a place to put something. And then within that, we have our cases. And so inside the Raphael case, we use a structural directive for ng switch case, and so on and so forth down to the splinter where we use a structural directive for the switch default. So sometimes it's square brackets, sometimes it's structural directive with stars. We have to import them all, and it's just kind of weird. The new way reads so much better. @switch on the color that we're switching on. @case red, within a block, we're going to show you Raphael. Case orange, we're going to show you Michelangelo, etc. Down to case default, we'll show you Splinter. We don't need to import all of these things. It's more lines of code overall because of the formatting, but it's actually much easier to read and understand, at least for me. And even better, we've gained type safety. In the old way, if red didn't match the type of what color was, we wouldn't actually know. But now, if there's a mismatch of type between red, orange, blue, purple, and color, it's a compile time error, and we get that information to be able to fix it. So overall, we get smaller bundles because we don't need to import these structural directives anymore. Better performance, especially with track. Better type safety, especially with switch. And it's just better code, easier to read and write than before. So the status of this, it's in developer preview as of November, and I use it every time I can. And now Donatello is going to help us with the last item, deferrable views. This one's a bit different than the other things I've talked about because this one's actually a whole new feature for our users. The other ones are all new ways of doing things we could do already, but this one actually opens up doors that we didn't have before. It allows us to lazy load add views. Now, we've had lazy loading in Angular for a long time, but it was route-based lazy loading. So essentially, when you opened up a whole new page within your application, that entire page could be deferred loading, which is great for performance, but it was a pretty coarse level. What if instead of the entire routed page to be lazy loaded, you had some component at the bottom, maybe all the comments on a blog article or something that you only wanted to load later if the user asked for it. So you wanted to defer the loading of that till the user scrolled down to that part of your page or till they clicked a button or something like that. You could kind of do that in some really difficult ways that almost no one did in Angular before, but you essentially couldn't do it, not really well. But now it's incredibly easy. So the syntax that we see here at the bottom is the new syntax. Again, we use the @ sign, so @defer, and then we have a block on the things that'll be deferred. Now, the onIdle is a trigger. There are several built-in triggers, and I'll talk about them. And onIdle is the default. So I don't actually need it there, but I put it there to show the example. And idle means when the browser is ready. So after the browser has loaded anything else and rendered anything else on that page, and it has nothing else to do, then go get this information and put it on the screen. But the get information part of that only works with standalone components. In this block, I have two components. The app idle is a standalone component, and app non-standalone isn't. And the display of both will be deferred, but the loading will only be deferred for the standalone component. So this is another advantage we got with standalone components. Once we have that in place, there's some optional other placeholders. We could put app placeholder in for what will show before the trigger gets invoked. And at loading will be there to show what will be displayed after the trigger is invoked. And then if there's some error in the loading, we will show what's ever in @error. Again, all three of those are optional. Additionally, placeholder and loading have some optional arguments to help you set the time. So in this particular case, we're going to show one of them for up at least 2 seconds and the other for at least 1 second, so that the things will be on the screen long enough for the user to read, and it won't be this weird flicker on the screen. Now, because this is user visible, I'm going to jump to an app and show this. This is a step in the Angular Bootcamp curriculum. So what we see here is the example for idle. And down here at the bottom, we have two components. The top one is a standalone component, and this bottom one in the box is not. And you'll see what happens here in this area when I reload. We initially get this placeholder that is there for 2 seconds, and then these other two things come in. But the important part is if we look over in the Network tab, we can see that there's a special bundle specifically for this idle component. Now, the timing for this, you can't really tell exactly what happened because it's such a small application that the browser got to idle really quickly. So you don't really see the delay before it came in. But you can see it's a separate bundle at the bottom. That standalone component was loaded separately, which means our initial load didn't need to include it. So our initial load to the first contentful page was quicker. We have some other triggers, though. We have a viewport trigger. So let's say we want to wait until something is scrolled into the screen. Maybe it's at the bottom of the screen, and that's where the heavy thing is. Well, in this scroll pane, I have a component at the bottom that has deferred loading. So when I scroll down to the bottom, it shows up here. This did not exist in the browser until we were about ready to see it on the screen. We can do interactions. So when I click on this placeholder here, then it will bring it in. So I'm going to click right now, and I clicked, and that brought it in. We can do a similar thing with hover. This will come in as soon as I hover over it. And you can see these are being brought in from the server. There's an immediate option, which comes in even more quickly than the idle. There's a timer option after 3 seconds. Then it brings in the value, and then it started loading. And you can create your own triggers. What I've shown you so far are the built-in ones. You can create your own. I created one that this value here will be replaced once the value up here is at least 3, or sorry, greater than 3. Boom, then it brings it in. And there are more options in these as well, but those are the key options. So as I said, you can create your own triggers in addition to the 6 built-in triggers for loading and prefetching. So the status of this is similar to the new control flow. It was also brought in as developer preview in 17, and it works really well. I haven't really used it much in my applications yet, but I'm excited to see what the community will use these for. And note, both of these use this new at syntax, which existed nowhere else in any framework before. So you might need to update your editors to get it, or if you use a formatting tool like Prettier, you'll have to update that. For example, Prettier has to be at least 3.1.0 in order for this to work. So those are the main 4, but Splinter points out there's a lot more going on. There's faster builds with Vite and ESBuild. There's new server-side rendering and hydration. There's new component lifecycle hooks. There's actually a whole new documentation website. This is officially beta right now, but it will soon be the true website for Angular. And it is built with these tools. For example, if I scroll down to the bottom, we bring in a lazily loaded playground that you can play with, and you can write Angular code here in the left and a server on the bottom, and the preview will come out here in the upper right. And what I really like on this page is a tutorial. They have this new tutorial here that uses similar technology. So if you want to learn more about control flow, again, they have Stack Blitz embedded in here so you can work on this. You get a little lesson with some exercise on what you need to do to try to get it to work in the preview. You can reveal the answer and see the result. It really just works well together. It's a great new site. And there's a lot more. This is the blog post from the team that announced it all. So thank you for watching this. I hope this was useful for you. The whole Turtle team thanks you for your participation. At the bottom here, you can see my individual information. And if you want to get these slides, you can scan this QR code or just go to the link tinyurl.com ngren ODSI. And if you want to learn more about Angular, please come visit angularbootcamp.com and we would be happy to talk to you about setting up a class. So thank you, and I hope you're as excited about the Angular Renaissance as I am.